One learning target, find angle and arc measures formed by secants and tangents. And that seems like a lot of different things in one learning target. It's going to be a little bit simpler than it might sound at first, okay? But there's three different situations that we're going to face in this section, okay? And they're worked three different ways. There's three different ideas we're going to have to be able to keep straight. Because I'll warn you, what's happened in years past is sometimes you'll forget. Because in one situation, the measure of an angle is going to be half the sum of two arcs. In a different situation, the measure of the angle is going to be half the measure of the arc, which we've faced before. And then in the third situation, the measure of the angle is going to be half the difference of the measures of two arcs. And as you can imagine, if you forget which one's which, you're sunk. Okay? So starting on page 727, we need to know, if we're going to talk about angles and arcs formed by secants and tangents, we should know all of those words except for the word secants. We need to know what a secant is. So, a secant is a line that intersects a circle in exactly 2 points. So, a tangent line intersects a circle in exactly 1 point. A secant intersects a circle in exactly 2 points. In other words, it goes through the circle. It doesn't have to go through the middle of the circle. It just goes through the circle. Okay? In one part, out the other. When two secants intersect inside a circle, the angles formed are related to the arcs they intercept. So here's our first theorem, our first situation for today. If two secants or chords, because look, if I draw these in as secant lines, didn't I also draw in a chord and a chord? Okay? So if two secants or two chords intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. It's like this. See angle 1 in the drawing? Angle 1 is formed when those two secants intersect, isn't it? See angle 2, or not angle 2. See the vertical angle to angle 1 in the drawing. I'll call it angle 3, just have something to call it. This theorem is saying that the measure of angle 1 is half the sum of the arcs intercepted by angle 1 and by angle 3. Okay? So it's half the sum. So we're going to add them together of the measure of the arcs intercepted by the angle, so the red arc that's intercepted by angle 1, and its vertical angle, so the red arc that's intercepted by angle 3. So we add together the measures of arc AB and arc CD, take half, and that's the measure of angle 1. Now, since angle 3 is its vertical angle, that's also the measure of angle 3, isn't it? Okay? Now, they drew this so that angle 1 and angle 3 are central angles, and I wish they hadn't have. They don't have to be central angles. Okay? So, what we're going to have to remember is this. Not necessarily as a formula, but remember it as the measure of the angle formed when two secants intersect inside a circle equals half the sum, and I'm going to just say the intercepted arcs, half the sum of the intercepted arcs. And then we have to know which two are the intercepted arcs. It's the one intercepted by the angle we're trying to find and the one intercepted by the vertical angle of the one we're trying to find. Okay? All right, let's see how that works. Let's try number 1 on page 731. They want us to find the measure of angle 1. And as is common at this point for us, if segments appear to be tangent, then they are tangent. Okay? Doesn't come into play in number 1, but it will in a minute. All right, so to find the measure of angle 1, according to our theorem, since angle 1 is formed by two secants intersecting inside the circle, or two chords intersecting inside the circle, the measure of angle 1 equals 1/2 the sum of the intercepted arcs. Angle 1 intercepts the arc with the measure of 134. Its vertical angle intercepts the arc with the measure of 86. Okay? You with me? Now it's a calculator problem. So the measure of angle 1 equals, well, let's add 134 plus 86, and then multiply it by 1/2. So the measure of angle 1 is 110. Make sense? Look what I'm doing here on the screen. What's the measure of angle 3? It's also 110, isn't it? What if they'd asked us for the measure of angle 2? 70. Now that I know that's 110, these two form a linear pair. So look, things that we learned way back when can come into play again, can't they? Okay? All right, let's do number 2. This time they ask us for the measure of an arc. So they want us to find the measure of arc TS. But we're going to use the same theorem. It's just that our unknown value is in a different spot when we write the equation. Okay? Since that 126-degree angle is formed by two chords intersecting inside the circle, that measure, so instead of writing measure of angle 1, I'm writing the measure of the angle, 126, equals half the sum of the intercepted arcs. The measure of one of the intercepted arcs is 108. The measure of the other intercepted arc, we don't know, so I'll call it x. And now we solve this equation. Does the equation make sense to you? It's the same equation I used for number 1. It's just that the unknown is in a different place. Does everybody see that? Not really? All right, so here's what number 1 looked like. We had the measure of angle 1, and number 2, we knew what the measure of angle 1 was. So I'll put the number instead of the symbols, measure of angle 1, equals 1/2 the sum of the intercepted arcs. We knew that one arc was that, and we knew the other arc was that. The difference in number 2 is we know that measure, it's 126. We don't know that one, so we call it x. Does that help? Okay. All right, so now to solve this, we can clear fractions. We cannot clear fractions. It shouldn't make a whole lot of difference. I'm gonna let you use your algebra skills. If we decide to clear fractions, which is never really a bad idea, I want to multiply both sides by 2. So 2 times the left side, 2 times the right side. What's 2 times 126? So I'd get 252 equals. Now the reason I'm multiplying both sides by 2 is because 2 times 1/2 is 1. So then I get 1 times 108 plus x, and I just get 108 plus x. Now all I have to do to finish this off is what's 252 minus 108? And that is the measure of arc TS. Okay, make sense? All right, everybody's with me. All right, let's learn about our second situation that can come up with this learning target. It says, recall that Theorem 10.6 states that the measure of an inscribed angle is half the measure of its intercepted arc. Where's the vertex of an inscribed angle? On the circle or on the center of the circle? On the circle. When the vertex of that inscribed angle is on the circle, the measure of that angle is half the measure of the intercepted arc. Now, if one of the sides of this angle is tangent to the circle instead of being a chord of the circle, this relationship still holds. Here's what it's saying. If a secant and a tangent intersect at the point of tangency, then two angles are formed. Look at the figure. Angle 1 is formed and angle 2 are formed when that secant line, line AB, intersects that tangent line, which they didn't give us a name for, at the point of tangency. Then the measure of each angle formed is 1/2 the measure of its intercepted arc. So, in this figure, the measure of angle 1 is half the measure of that red arc, arc AB. The measure of angle 2 is half the measure of this blue arc, arc ACB. Okay? So, these angles work like inscribed angles. And I want you to think of it that way because the vertex of an inscribed angle is on the circle. The vertex of these two angles is on the circle. Okay? So the measure of the angles, half the measure of the intercepted arc. Number 3. They want us to find the measure of angle 2. This time we have a tangent segment. Segment AB is in fact, line AB is a tangent line. Point B is the point of tangency. So, the measure of angle 2, since the vertex is on the circle, the measure of angle 2 is half the measure of the intercepted arc. So the measure of angle 2 is half the measure of 146, or just half of 146. What's half of 146? And that's the measure of angle 2. Now, they don't ask us this, but could we find angle 3 now that we know angle 2? Yeah, because they form a linear pair, don't they? Okay? All right. Our last situation that happens with secants and tangents intersecting. The secants and tangents can also meet outside the circle. So far, we've intersected two secants in the interior. We've intersected a secant and a tangent on the circle. Now we're going to intersect them in the exterior of the circle. All right, so if two secants, or a secant and a tangent, or two tangents intersect in the exterior of a circle. So look, this can look three different ways. This is two secants intersecting. This next figure is a secant and a tangent. The next one is two tangents. But here's the thing to notice. Where is the vertex of the angle in each case? Exterior of the circle. Exterior of the circle. Exterior of the circle. So, when the vertex of the angle is in the exterior of the circle, then the measure of the angle formed is 1/2 the difference. Some mean add, difference means subtract the measures of the intercepted arc. So, here in figure 1, the measure of angle A equals half the difference of the big arc, arc DE, minus the little arc, arc BC. Figure 2, the measure of angle A equals half the difference of the big arc, CD, minus the little arc, BC. Figure 3, angle A, the measure of angle A equals half the difference of the big arc, BDC, and the little arc, BC. It's not as complicated as it could be. It's always the measure of the larger arc minus the measure of the smaller arc. It's always large minus small, okay? Because otherwise you get negative, and that's not going to make any sense. Let's do one. Number 4. Find each measure. If it looks tangent, then it is. So we're supposed to find the measure of angle H. Good, that's what I wanted to find. According to our theorem, since we have two secants intersecting in the exterior of the circle. The vital bit of information is they intersect in the exterior of the circle. The vertex of the angle is in the exterior. Then the measure of that angle equals 1/2 the difference of the intercepted arcs. So 1/2, and then the measure of the big intercepted arc, 88, minus the measure of the little intercepted arc, 26. Well, what's 88 minus 26? 62. So the measure of angle H is 1/2 of 62. So the measure of angle H is 31. Questions? Now, like we did with our first situation, we can move the unknown around, okay? So before we go on to another example, if I have this same setup, measure of angle H equals 1/2, 88 minus 26. Wouldn't I use that same equation if I already knew that and I didn't know that? Right? See what's going on? So your unknown can move around, but it's still set up the same way. The measure of the angle equals 1/2 the difference of the intercepted arcs. Number 5. The vertex of this angle is in the exterior of the circle. In fact, it's formed by a secant and a tangent. So the measure of that angle, and instead of writing measure of angle H, I know what the measure is this time. It's 71. Equals 1/2 the difference of the intercepted arcs. Now, I don't know the measure of the big arc QTS, do I? So that'll be my X. And I do know the measure of the smaller intercepted arc. It's 106. All right, does that equation make sense to you? Okay. I'm going to clear fractions by multiplying both sides by 2. That'll give me 142 on the left, and it'll give me X minus 106 on the right. All I've got to do now is add 106 to both sides. So what is 142 plus 106? So 248 is the measure of arc QTS. All right, any questions? Number 6. Go ahead. Work. You get what I got? Any questions? All right. You just got to remember, when the vertex is in the exterior of the circle, the measure of that angle formed, whether it's by 2 secants, 2 tangents, or one of each, is half the difference of the intercepted arcs. All right, on page 731, they give us a summary. So if you get confused, and if you forget which one works which way, vertex on the circle, the measure of the angle is half the measure of the intercepted arc. Vertex inside the circle, the measure of the angle is half the sum of the intercepted arcs. The vertex outside the circle, the measure of the angles, half the difference of the intercepted arcs. So you're going to have to be able to remember that and keep all that straight. Okay? All right, your assignment. Page 731, do 1 through 6, 8 through 16, 18 through 25, and 42 through 45.